This is 2.5, Quadratic Inequalities and Systems of Equations. And honestly, the material in this chapter you've already seen before. There is nothing new in this section of the chapter, and we'll show you that. So here's the one problem from the homework. It says solve the following quadratic inequality. And notice that this is an inequality, not an equality. If you had a parabola, if you say ax squared plus bx plus c equals 0, then what you're identifying are the x-intercepts. And this is where we FOIL, or where we complete the square, or we use the quadratic formula. It's always equal to 0. And that's what you're finding. You're finding where on that graph, for what x-coordinates, are the y-coordinates 0. We're changing this from an equation to an inequality. So here is the location where you have positive y-coordinates, and here's the location where you have negative y-coordinates. So if we change this from an equals to greater than 0, where is the function greater than 0? This is where the function has positive y-coordinates. So for the inequality greater than, you are looking at positive y-coordinates, which will be this segment of the graph. If you have the inequality less than, then you're looking at this segment of the graph where it has negative y-coordinates, which would be here. So this is where your inequality, you would have ax squared plus bx plus c is greater than 0, and this is where ax squared plus bx plus c is less than 0. And this is where ax squared plus bx plus c equals 0, here and here. So we have x squared minus 11x plus 30 is less than or equal to 0. And what you need to do is solve this inequality for x. You got to find the x-intercepts. And there are 3 ways you can find the x-intercepts. The first way is you could unfoil this. The second way is you could complete the square. And the third way is the quadratic formula. Give yourself 10 to 20 seconds. Let the tumblers in your head click around and see if you can come up with factors of 30 that add up to negative 11. This factors into x minus 5 and x minus 6 less than or equal to 0. So that means the x-intercepts are positive 5 and positive 6. This was easy because we could unfoil it. If we could not unfoil this, then you would have to go through complete the square or quadratic formula, your choice, to obtain those x-intercepts. Let's sketch this. I can't figure out what this graph looks like just from the x-intercepts, because maybe the graph looks like this. Maybe it looks like this. Maybe it looks like this. Maybe it looks like this. Or like it is super narrow, I don't know. So we need one more point. X-intercepts are nice, but we need one more point to orient this parabola. And the point that you pick is kind of up to you. Some students might pick the vertex. Other students might pick the y-intercept. I'm going to go with the y-intercept because I can read it right off of the graph. Or not off the graph, off the equation. 30 is the y-intercept. So I know that this goes through the point 30, not drawn to scale. So that means that my parabola has to go like this. And really, the shape of the parabola doesn't matter, right? Like I can be sloppy like this because I have all the information I need at this point. We are looking for where is this function less than or equal to 0. And where is this function less than or equal to 0? From here to here. How would we write this interval? So we actually have like a closed dot here at 5, and then another closed dot here at 6. So I'm going to go hard bracket, 5 comma 6. And that's the solution. That's the set of x's over which the function is less than or equal to 0. Just for fun, why not? Where's the function greater than or equal to 0? So if we asked where is it greater than or equal to 0, well, that's going to be this segment and this segment. And so how would you write those in interval notation? How about negative infinity to 5 with a hard bracket? Union with 6 to infinity with a parenthesis. Yeah, good. How do we make it more difficult? We make this step right here more difficult. We make the factoring more difficult, right? We're going to give you an equation that's not so easy to factor. You're going to have to spend 10 minutes completing the square to get your x-intercepts. But once you get them, you plot those x-intercepts, you plot the y-intercept, you sketch your graph, and then it's just thinking from there on out, right? Like looking at the graph and saying, where's it above 0, where's it below 0, and I hope I did my brackets and parentheses right. This one was a little bit tricky. Not all parabolas have 2 x-intercepts. Sometimes they only have 1 x-intercept, or in a parabola that maybe looks like this, no x-intercepts. So this one happens to have 1 x-intercept. And the function says, where is this less than 0? Not less than or equal to, just where is it less than 0? And you can see from the graph, y-intercept is 36, that this has no x-coordinates where it's less than 0, where the y-coordinate is less than 0. On the other hand, just for fun, if we ask where's this function greater than 0, everywhere this function is greater than 0, from negative infinity way out here all the way to positive infinity. We'll go right to quadratic formula. So opposite of b plus, and I'm going to do opposite of b over 2a, plus or minus the square root of b squared minus 4ac all over 2a. And again, this is how I like to write the quadratic formula. And the reason I like writing my quadratic formula split like this is because this is my axis of symmetry, and it is also the x-coordinate of my vertex. All right, so let's, plug in some numbers. Now I've got to do some arithmetic. So this is your answer. So your left-hand x-intercept is going to be negative 7/6 minus 17/6, which is negative 24/6, which is negative 4. Fantastic. Your right-hand x-intercept is going to be negative 7/6 plus 17/6, which is 10/6, which is 5. All right, so now we've got the x-intercepts. Let's sketch a graph. Great. What's our y-intercept? Looks like negative 20. So down here somewhere at negative 20, that's your y-intercept. So that means our graph, oh, and the other thing you could do, if you wanted to, is remember that we have this axis of symmetry already identified, negative 7/6. So that means at a little bit bigger than negative 1, we've got an axis of symmetry going right down there, and on this axis of symmetry is our vertex, which is a minimum point in this case, right? Because everything else is above it. So we'll just put a dot there, and if you want to know what that point is, go ahead and calculate it. That's great. So then you kind of sketch something like this, and then something like this on this side. And remember, this is my y-axis and this is my x-axis. So there's a lot of different colored lines flying around here. Try not to get confused as to what's what. And then finally, now that we have this sketched roughly, we need to ask, where is this less than or equal to 0? Where is it below sea level? And I'm going to go from here all the way to here. That's where the function is less than 0, less than or equal to 0. So anyone want to take a crack at that interval notation? Done. Remember, previously, we did something like this. We would give you a line that looks like this, and we would give you another line that maybe looks like this, and we would ask you, what's the solution to the system, which basically means where do these lines intersect, and you would find an ordered pair, an x and a y. And that would tell you where they intersect. That was when we were talking about lines. What are we talking about in this chapter? What type of shapes? Parabolas. So we're going to give you a parabola maybe that looks like this, And then we're going to give you a parabola that maybe looks like this. And we would like to know, where do these parabolas intersect? Same concept as lines, except for now it's parabolas. Here's your two parabolas. What variable do you want to eliminate? The suggestion is take this first equation and make it negative. So we're going to say negative x squared plus 2y equals negative 4. And then we just do nothing to the second equation. X squared plus 5y equals positive 4. And we add them up. And we get 7y equals 0. How about that? So y equals 0 divided by 7, which is 0. Right, so y equals 0. This is the y coordinate of both intersection points, 0. What are the x coordinates? How would you find the x coordinate now that you have the y coordinate? Plug it in, right? So take y and plug it into either one of these equations. Just to show you that it works, I'll do it in both. So x squared minus 2 times 0 equals 4. X squared, this goes away, equals 4. X equals 2 or negative 2. And if you want to be fancy, you'd say plus or minus 2. We'll do that with the second equation. So we'll say x squared plus 5 times 0 equals 4. And you can see right away, you're in the same box. So this means x equals plus or minus 2. So what are the coordinates of the intercepts? Well, one coordinate is going to be 2, 0, and the other one's going to be negative 2, 0. So what do they want here? The two solutions of the systems are the one where x is less than 0. That's going to be this one. So we're going to say x is negative 2, y is 0. And the one where x is greater than 0 is going to be positive 2 and 0. And maybe you're just full of beans. He doesn't know what he's talking about. All right, let's see. Hey, look at that. All right, and let's do the next one. And this one we're going to make red. Zing. Hey, look at that. And where do they intersect? 2, 0 and negative 2, 0.